Right. The next technique would be to separate a solid-solid mixture. Is called sublimation. Okay, let's first understand when would we use sublimation and what is sublimation all about. Okay, so maybe let's deal with the definition first about sublimation. Okay, sublimation is actually known as the process of changing directly. Okay, usually as a result due to heating being involved, whereby a solid changes to a gas directly. So it does not go through the liquid state at all. Okay, so it turns from a solid to a gas immediately or upon heating. Okay, directly upon heating, not immediately, directly upon heating. Okay, so it will be useful if in your solid-solid mixture, one of the solid is able to sublime or undergo sublimation. Okay, so it is therefore critical for you to know those few substances that can sublime, so that when you're given the identity of the solid-solid mixtures, right, you can single out, oh, this particular solid is what I actually recall from what I've learned, is a solid that can sublime, and therefore sublimation is one method to separate the solid from the other solids in the mixtures. Okay, so the first one you really must know is iodine. Okay, the second popular choice is actually solid carbon dioxide, which is also known as dry ice. Okay, followed by ammonium salts and then naphthalene. Of course, it will be good that you can remember all of it, but minimum would say 2 or 3. Okay, so I've actually given you the priority list in terms of knowledge. Okay, so let's go into the details about sublimation. How does it work? Okay, once my solid turns into a gas, how then do I recover it? Okay, so here we are given a solid-solid mixture again. So I have solid iodine and I have sand. Okay, and this iodine, we know it will sublime. Okay, so what happens is, right, okay, they will place this mixture into a beaker, okay, and then heat is supplied through a Bunsen burner. Okay, so once the mixture is heated, iodine, okay, being the solid that can sublime, will turn into a gas over here. Okay, and you will actually see as a purple gas. That's the color of iodine vapor. Okay, but we cannot just let the gas escape. So because eventually we want to recollect back the iodine that has sublimed, so we will usually place an apparatus. It can be an evaporating dish, it can be any form of a watch glass, etc. Probably with cold water or ice, okay, so that it keeps this surface cold. Okay, so when the hot vapor, of iodine gets into contact with the cold surface of the evaporating dish, it will revert back to the solid state. Okay, so the gas turns back to a solid over here, and you will see all the iodine crystals at the bottom of the evaporating dish. You can scrape it off and then you can recover your pure iodine. Okay, why is it pure? Because the sand cannot sublime, so the sand will be left behind, okay, at the bottom of the beaker. Okay, so there is a special name which you need to be aware of. Okay, this solid deposit, which is in this case iodine, okay, is called the sublimate. So this is the sublimate. Okay, now I have with me a video about the sublimation of iodine, so you can actually take a look at the video that is below this particular lesson. Okay, to view how sublimation of iodine looks like. Okay, so with this, we have actually completed the first section on solid-solid mixture. Okay, let me just blow this up. So we have already covered magnetic attraction, sieving, suitable solvents, sublimation, the 4 techniques to separate solid-solid mixture. It all depends whether you have a solid that is magnetic, very different particle size, different solubilities in the same solvent, or a solid that can sublime. And you need to know your examples of solid that can sublime.